Hi all. Uh, we are going to conduct a series of lectures on the topic numerical linear algebra based on the book beautifully written by Trapton. The content has six parts, and the first part is about the fundamentals of numerical linear algebra, like what are the properties of the vectors and matrices, like orthogonal properties of vectors and matrices. What are the different norms utilized for identifying the norms for the vectors and matrices? And finally, they give some algorithmic overview of the most important algorithm called singular value decompositions. And the second chapter would be related to the QR factorization. This is also a very vital part of the numerical algebra, and what is meant by orthogonality, and what is meant by orthogonality of two vectors, what is orthogonality of matrices, and how do we compute orthogonal vectors from the normal matrices using a two algorithm called Gram-Smith orthogonalization and Householder triangularizations, how these two algorithms are utilized for solving least square problems. So when it comes to least square problem, there are different way of solving it. One is like making a normalized system of equations and trying to solve it, but unfortunately due to floating point arithmetic, it's not that prone to be a stable. So how these QR factorizations using householder triangularizations and QR Gram-Smith orthogonalization helps us to solve this least square problem is very important in terms of machine learning, like statistics. Like most of the systems are over determined systems where you have large amount of data. And the fourth part would be like solving a system of linear equations using a direct method like Gaussian eliminations method, LU decomposition method, and Cholesky factorization methods, and how we make a stabilization using a concept called pivoting. And fifth would be another important concept called eigenvalues of the matrices. How do we compute the eigenvalues and eigenvectors of the matrices using an direct method called Q algorithm? Is one of the top 10 algorithms of the 20th century. And finally, we give some algorithmic, like how do we compute a singular value decomposition using these concepts. And the final part would be like iterative algorithm, because most of the matrices occur from physics are large and sparse matrices, where a direct algorithm will give you a computation cost about order of n cube at least. So, like iterative methods will help us to solve linear system of linear equations using methods called conjugate gradient method, which is a symmetric method. And other methods called GMS methods and bi-orthogonalization methods. And what is the concept of preconditioning to reduce the number of iterations. And also, we give some overall idea about how do we solve the eigenvalue problem for large and sparse matrices using iterative methods like Arnoldi, Langsos, and Arnoldi methods. Hopefully, we will start from the next video of the series, covering all these six chapters, each of them having um, a set of lectures. And hopefully, we'll see in the next video on the first chapter of this numerical linear algebra, giving us some basic introductions about the vectors and matrices. Thank you.